You're welcome.
So, okay, so I want you to write these for displacement. So we already talked about how acceleration is going to be based on the slope of them, either positive or negative. Displacement is what? What are we looking at?
Area.
Area.
Area under the curve.
Area under the curve.
And so be careful, displacement is not the same as distance. What's the difference?
Distance, you would add the areas positive or negative, so it would be the absolute value of both. And then for displacement, you would subtract the positive area by the negative area.
Yeah. So make sure you're taking into account positive and negative area, as well as if they're adding and subtracting, all positive, all negative. Go ahead. Have you guys already ranked them in your heads?
Yeah.
Mm-hmm.
Okay. What's our order? Greatest to least.
C
No, it would be
equals
F is greater than C.
Yeah.
Okay. FC. Then what?
C equals A.
Yeah.
And B equals G.
What about the ones that have 0?
Oh, what about those? Are
Those
they
just come before the negative.
So D would be negative, so that would be the last one. F would equal 0, and then H would equal 0. So F can't be the
E, you
greatest.
mean, not me.
Oh, E, yeah, E.
Oh, that's not an F. Oh.
Sorry, that's an F. That's an E.
Oh.
So E equals H. All right, we okay with this order?
Yeah.
All right, let's do the opposite. Distance. So this is displacement if we care about positives and negatives. What about distance? What would be our order for distance?
F is equal to D.
Mm-hmm.
A is equal to C, which is equal to
A, C,
B,
and G are equal.
and then
And B is equal to that as well.
H. And
A is equal to B, is equal to C, is equal to G.
what about H and E, Navi? Because it's absolute value, right?
Yeah, H and E, that would be,
Equal
okay,
to
so
A.
20 times 2, 20 times 2, that's 40. 40 times 4, 80. So those would be the least. They would have the least.
It has the least.
H and E would have the least distance. Because, yeah, would they have the least? Because they're two triangles, so it would just be 20 times 2. 20 times 2 would give you 40 as your distance.
Huh? What's the area of G?
Navi, but also A. And
Oh, they would be equal?
they're equal.
Oh, shit. Oh, my bad.
Yeah, so be careful. A lot of things change when you switch to absolute value, so keep that in mind. But overall, how do we feel about kinematics graphs? Because those in some way tend to come up.
Kind of good.
Okay, so
Wait.
probably yes.
Sorry, for the, you said G is equal to H?
Yeah, because basically if you actually calculate it out, this area, it's a triangle, so 20 times 1/2 of 20 times 40 gives us, and this area is, you could look at it as two triangles like this, or like this. And again, this one is a base of 2 times 20, so this area is 20. This area is 20, because we went up to 20, and then we turned around and we came back to the original spot. So ultimately, our displacement is 0, ended up in the same spot, but we went 20 there, 20 back. This is also a total of 40, which means all of these ones with this slope and these ones here where they go forward and back actually are the same, even though it doesn't look like they should be because the slope is different. And that's why you want to just be really careful when you're dealing with area, because sometimes even though the area doesn't necessarily look the same, probably also because I drew it poorly, it is. So you always want to double check that. A good question. All right. Have you guys heard about what's going on with school?
What?
About grading and other stuff?
Oh yeah.
All right. What have we heard so I can clear anything up or add anything?
So I guess schools are doing, like, majority of the schools are doing the pass fail instead of the grades, and then there's gonna be no GPA.
And juniors don't have to submit their SAT or ACT scores when they apply next year to college.
Yeah.
Our college application process is gonna be more lenient, pretty much, like, overall.
Yeah.
Wouldn't they in like, since they usually focus on like SATs, GPA, extracurriculars, or like PIQs, won't that mean they'll care even more about like extracurriculars and stuff because they will have one less thing to grade you on?
Yeah, it's going to matter a lot more. Both your sophomore grades will probably be more important for juniors because of this. Your first semester of your junior year will be more important, and probably your first semester of your senior year will be a little more important as well, just because they're not going to have a whole lot of information on this time. And so they're not going to require them. If your scores are good, go ahead and you already took it, or you find a way to take it, submit them. If your scores aren't good and they don't require it, don't do them. Don't send them. So for CSUs, this doesn't change a whole lot for their admissions process. For places that do use essays, you definitely want to really work on those essays, because those essays are probably going to have a bigger effect than they would before, because there's only a couple things they can look at, and the PIQs are the only probably true like free ground now, because GPA has been messed up, ACT, SAT stuff has been messed up. PIQs are the only current fair like level playing ground for everyone. You all get PIQs at the same time, you all put them in at the same time. So definitely make sure next year when you're applying, you work extra hard on PIQs or essays. So
is there anything like else that like affects us seniors?
Seniors, I think just make sure you do pass your classes. So pass, not pass basically means a pass is an A, B, or a C. Not pass is a D or an F. I'm sure the school's going to come out with like weird guidelines or something, but in my mind, when I was in college, because in college you can take things pass, no pass. It's actually pretty common. Normally, it's like when you're taking an elective that has nothing to do with your major, but you just needed a couple extra units, and you don't really care about the class, and you're like, I just need credit. There's a certain amount you can take pass, no pass, but a lot of times you'll take those random like literature class that you had to take, or like winemaking, or like these little random classes. Often you take them pass, no pass. That way you're not worried about a grade and you can focus on your other important classes, but you can still take it and learn some things and have some fun. So for seniors, it shouldn't affect you in the slightest unless you do not pass a class. Even then, I imagine schools are going to be a bit more lenient this year just because things are crazy. Yeah. That kind of settle things for everyone. And then for juniors, I will therefore, if this is being taken pass, no pass, if you do well on the test, and seniors, if you really want me to, I will change your first semester grade, because I don't know if I can give you the grade bump you want on your second semester grade, which is what I would normally do. So I'll still find a way to honor the idea that if you do well on the test, I will try to bump your grades. I'll try to do second semester if they'll let me. If not, I will go back and do it to the first semester.
What happened?
Hello? So somehow I'm a participant
Yeah.
of this meeting anymore. I don't know what happened there.
No,
Wait,
it
who's
still
host?
says
Yeah.
you're the host.
Oh, it does say I'm the host? Okay, cool. Cause yeah, I
Yeah.
somehow lost connection there. That's unusual. But I'm back now. So interesting. I wonder if just because there's so many internet users now. Do we lose anyone? Maybe. Kind of looks like less. Oh well. All right, so you guys ready to go over the practice test?
Yeah.
Yeah.
Okay. Do you want to do free response or multiple choice first? All right, free response. So I'm going to screen share.
Actually, go over the. Never mind.
Okay, I'm going to share my screen so you guys I can go and look at scores. So overall, oh, and here's exam schedules if you want them. Where is it? I just had it up. Okay. So overall, I thought we did pretty good on the multiple choice. But let's go. Oh, I need to go to second period. Still not terribly enjoying. And so we got over half the class taking it, which is actually pretty good considering it's a weird system. Whoever's making clicky noises, you can mute yourself. Thank you very much. Navi, you said, look, we can look at yours. All right. So let's look number one. So number one was a circuit problem. We are going to go over this. Obviously, it's less big of a deal because it's not actually going to be on the test. But so we have this circuit. Let's look at the question. So we have this circuit. And, oh, right, this question. Okay, cool. So we actually just did a question very similar to this together, right?
Mm-hmm.
Excellent. All right, so first off, we want to rank the current correctly. And so what do we know about the current based on this?
3 and 4 are going to have the same current.
Yep, 3 and 4 are equal, which are...
Can we not do mine?
No? Okay. Well, then I can just show the question, and this is the scoring guideline.
No, I'm just playing. You could go ahead.
Because I can just do the scoring guidelines. I don't have to read yours if you don't want
No,
me.
I don't mind. I know it's wrong, but.
So you got the R3 and R4 are the same, but did not split up the parallels. And so yeah, so our biggest currents would be through R3 and R4, and they say I3 and I4, so just kind of be careful with notation there. Because R stands for resistor, I stands for current. So make sure you do switch your numbering accordingly. Again, not going to be a big deal on this test, but it is something I have seen people lose points over, and it's like, no. So yeah, 3 and 4 are the same because they're in series, and then 1 and 2 are split. So you have to care about which one has a larger resistance. Let me get my spotlight on.
But I was thinking that because resistor 4 is bigger, so it would pretty much, because doesn't the resistance or the current depend on like the biggest resistor?
The total current depends on all the resistors.
Oh yes.
So whichever one's biggest is not necessarily important. If they are in parallel, like these, where your electron has a choice, then it absolutely does matter because they can choose which one they go down. If it's a forced path, then it's going to just be the total. Whatever the total is, it's going to get it. And since resistor 1 here is less, it's going to get more current. So this is the correct ranking. So you actually did earn 1 point for the correct ranking here. It also, so something indicating that series have the same current, that's why I3 and I4 are the same, gets a point. explaining why I2 must be smaller than 3 and 4 in terms of the idea of the current splits, aka the junction rule. And then one thing explaining why your parallel gets different current because of the different resistance split. So V equals IR or something along those lines. Do we have any questions on part A? No? We want to move on? Question? All right, part B it is. So part B is now we have some students actually doing some stuff here. So they're connecting voltmeters to 1, 2, and 3, and 4, and they're getting these different readings. So they want you to determine what the voltmeter readings are. And so basically you could have made a V equals I chart for this, or you could have just done, it's basically a loop rule problem. And so we have these, can you see the whiteboard?
Yeah.
Do I need to draw bigger because we're screen sharing?
A little bit.
No, we can switch from your computer screen to your like actual camera.
We can?
Yeah, you just press it.
Oh, resize window to display more. Okay.
And so basically they're telling you that, let's see, what did they tell you? They told you that 1 and 4 is 1 and 9. So this is 1 volt, and 4 is 9 volts, and it's a 15 volt battery. And so they're asking, with explanation, what the voltage is going to be. So if 1 is going to be 1 volt, what is 2 going to be?
Oh, 1 volt.
1 volt. Why?
Because they're in parallel, so they have the same voltage.
And so that gets some point, something of it's in parallel, it's the same. All right, what does 3 have to be?
5.
Same as 4? No.
It has to be 5 because it has to add up to 15. So if 4 is 9, then and then 2 and 1 are equal to 1 volt, then you just subtract.
Yeah, so for whichever loop we do, and that's why, and that's another reason why parallels are gonna have the same voltage, one whole loop has to add up to 15 volts. So if this area gives 1 volt plus, we don't know, plus 9 volts equals 15, that has to be 5 volts to keep the loop roll. And so, and there your points is something about how, so yeah, so here if you switch back to the screen share, it says R and 1 are in parallel, and then so you have to say something about the recognition they're in parallel and therefore have the same potential difference or voltage. In case you were thrown off by the words potential difference, that just is the same thing as voltage, aka the difference in the potential energy from before and after. And then something explaining how about the loop, how it has to add up to 15. And there's a couple ways you could do this. This would be a perfectly okay way to do it on that we did on the board. All right, we good to go to C?
Yeah.
Yeah.
All right. So C is a 1-point problem. C is just saying, well, we connect a wire from A to B. And so the idea is what is going to happen to the current? So if I connect a wire, what happens?
You add an alternative route.
Yeah, we add an alternate route. And so what does that mean?
Current will decrease.
Yeah, so you can think of it either 2 ways. 1, we add an alternate route. The current will increase because there's more pathways. Or you could also do it as in, we shorted this circuit, we shorted this resistor. And what shorting does means we bypass it. AKA, this resistor, according to the circuit, doesn't exist anymore. Because if you could choose no traffic or traffic, you're going to choose no traffic. So pretty much no electrons are going to go down that route. And so basically what you did is you created a circuit with one less resistor. So you lower the resistance, which also increases the current. So those are two ways you could explain the exact same answer. Both would be okay. Again, it's a 1-point problem, which means they're looking for anytime they say briefly explain, they're probably looking for 1 or 2 sentences. So if you're writing 3, 4, like cut yourself off. Either if it needs that many sentences, you're probably going down the wrong route. Or if you're just, getting a little long-winded, cut yourself off. Say it simply, move on. All right, we go with question 1.
Yeah.
Okay, so on to question 2. 2 was about rotation. Okay, and so note, 2 is extremely difficult to grade, and all lab questions are extremely difficult to grade because they always say, well, whatever works, which is an extremely annoying answer. So I'm going to draw this out. All right. And so again, in general, whenever you encounter a lab question, you do not need to go in order. And when I answer a lab question, I never go in order. I always do the analysis part first, because if you don't know how you're going to answer the question, you don't know what you have to measure yet. So I always start at the part where it says just B. So I always do part B, then I do part A, and then I go back to part C on these types of questions. So part B is describe how the data from the measurements could be analyzed to determine the frictional torque exerted on the platform. So I always want to figure out, well, how am I going to solve my problem before I decide, well, what data am I going to take? And normally when you're doing labs, if you kind of remember back to some of the SDLs we did in class, you had to think about first, how are you going to do this before you figured out, well, what data do I need to take? Because you could think of, oh, well, maybe this is useful, but then when you go to solve it, you're like, well, I didn't actually even need to take the mass. So you always want to do your analysis portion first and then go back into, well, what are you going to measure? How are you going to measure it? So let's think about this. We have a disk. Do you guys want me to stop the screen share for this? Does it matter?
Not really.
Okay. So we have a disk. And the question is, we want to figure out the frictional torque exerted on the platform. And so we sort of did things similar to this. So remember when we had the PVC T-posts? It was a 2-day lab. We were finding the rotational inertia of them.
The one where we spin them?
Yep. And so basically, one thing to get over is, what is frictional torque?
The torque created by the friction between the pole and the disc.
Yeah, that's it. So, because I remember, I think last year when some people took this, they're like, but you never talked about frictional torque. I'm like, it's just friction that slows it down. That's all it is. So it's just friction. It's just friction that is causing the rotation to change, or the rate of rotation to change. So it's nothing new. We're just looking at an external torque. And so if we want to figure out what the friction is, what sort of things do we need to know about it? Like, what do we have to do to solve this?
We have to find because they said that they already have the moment of inertia given, right? Or the rotational inertia.
Yes, we know the
We
rotation
already have that. And then
So then we could just look for a equation that has that.
Yeah, so you want to start looking for equations that have torque and this, and then what can you do to solve those? So what kind of equations do we know have to do with torque and inertia?
So there's an acceleration
Rotational.
one that gives us torque or the net torque, and then we have the torque equals R force sine theta,
Mm-hmm.
and then we have change in angular momentum is equal to torque change in time.
So which do we think is going to be helpful here? Or which ones if you think we need multiple?
The
The
first
last
one.
two, I think.
All right, why?
Because then we can substitute the change in L with the change in angular momentum. We can substitute the angular momentum with I Wombo, and then we can change it to I delta Wombo is equal to torque.
Like that?
That's what
I think it would be the first one because it's asking for the net torque of it, and I and like you can find we have the inertia, and so you would just need the acceleration, and I think we found acceleration somehow in that one lab you were talking about with the pipes.
We did.
So maybe we could use that.
And so you're both right. The answer is either this or this. So you could solve this either this way or this way because these actually are the same equation. Newton's second law is the same thing as impulse. Because remember, alpha is just the change in angular velocity over the change in time. And so these are actually the same equation, just written differently.
Oh, you just plug them in.
Yep. So either one would work. And so Alex, you did a really good job saying that we in some way have to talk about acceleration or get some way to get the change in velocity and the change in time.
So when I was doing that problem, I was thinking, what if we just have acceleration equal to 0? Then the force of or the torque of friction would be the same as like the torque applied.
Yeah, so that is, and so that's why it's hard to grade these because there's, I think I found at least 5 good ways to answer this that are different. And so that is one way. So one way you could do it is say you could attach, like we did before, you could attach some horizontal string and apply a force and therefore a torque. And if my net torque is 0, I know that whatever torque is being applied is the same as the frictional torque. So that is one way you could do it. What's another way we could do it?
Have the acceleration constant.
You could be more. So we could do sort of what we did in the lab together with the PVC pipes. You could hang something off of it and get your acceleration off of it. And so if you found your acceleration and you knew how much torque you applied, you could say, well, I know acceleration, I know inertia, and then my torque is whatever torque I applied minus the torque from friction. So if you get your acceleration and you get your torque, then you can figure out how much torque is being pulled against it. You could also literally just spin it and see how long it takes to slow down. Like you could spin it at a set speed, figure out what that speed is. Either you could use a photo gate, you could use, I would use a photo gate, honestly. You could even do an average and count it. And frictional torque is constant, so you can use any of the kinematics equations on this because the acceleration will be constant because friction should be constant. Does that kind of give you an idea of how to tackle this problem?
Yeah. Well, I have like a side note question.
Yeah.
What if we were to, for like one of the problems, what if we were like using calculus to like solve?
No.
No? Would they mark us down for that? Or?
Yes. So you can use the ideas of calculus, like you could say we could graph the angular velocity over time and find the slope to get the acceleration, but you can't say if we find the we'll find the derivative and then be like, oh, that's done.
So instead of saying like the derivative, we could just say like, and there's like a graph, for example, we could just say like the tangent at that point.
Yeah, so you can say the slope at that point, the tangent at that point. So you want to use algebra words. You can use the same ideas you've used in calculus. You cannot say calculus cannot be the replacement for physics reasoning. You still have to say, oh, well, we can find the tangent because the slope of a angular velocity line is angular acceleration.
So you just have to like have the conceptual explanation rather than like the mathematics. Okay.
And so, do I absolutely use calculus to help myself through problems? Yes, but it cannot be part of your explanation. And so basically, I'm going to use the one that, say, Navi did about making the force, the net torque 0 or the acceleration 0. And so part B would be this, where we talk about, well, if I have this, I can now do this and this and this and find my torque. That's when I would go back to A and be like, well, to do this part, I had to measure these things. And so the things we had to measure how much force was being applied. We had to measure our radius. And we had to measure, or essentially be able to figure out that it is not accelerating. And so, now let me just do something quick. All right, and so things you would need, make sure you are combining the idea that this needs to be measured, this is what I'm using for it. So if you say you're gonna measure the force, you have to say with a force probe or with a Newton meter or a spring scale. You have to state it. You would also have to state that we measured the radius with a meter stick, which sounds obvious, but you have to say meter stick or tape measure or some type of measuring device. And then as far as you need to have a clear way of how you're going to check the acceleration, whether that's because it's not moving, therefore it's not accelerating at all, your equilibrium, or you have, I always like to put a photo gate on these things. And to do that, for example, when I originally did this problem, I said I was going to attach a photo gate right here and then put like a little tiny stick on the edge of this and then let it go through the photo gate. Because then the photo gate will tell me exactly how fast it's going at any given time. Ruler works as well versus meter stick, but make sure you say some sort of acceptable measurement device. Meter stick is a little better than ruler just because we're measuring in centimeters and meters, but it's not that big of a deal. And then you would want to say exactly how we are doing this. Questions on this?
Mr. Coy?
Yeah.
So for which equation are the measurements going to apply for?
Honestly, both of them. Mostly, I mean, it doesn't really matter because you would have to in some way figure out that the change in velocity is 0 or that the angular acceleration is something. Basically, for these, there's two things you're probably going to have to measure. Some torque that you apply or some, or what's going on with the change in the angular velocity. One of the other common methods is literally you just hit it, like you spin it yourself, and then you measure how fast is it going, how fast is it slowing down. Because if you do that, you don't need to, sorry, I lost my train of thought trying to do something on there. So you have to measure how much it's changing its velocity. You could either do Navi's way, which is where you're pulling it such that there is no change velocity. Again, you have to make sure you have a way to prove it, either a motion detector on your thing, saying that that's falling at a constant velocity, it's not moving at all, it's in equilibrium, or you have to measure the change in velocity. You could put a photo gate onto this. You can measure how fast, if you put a mass on this, how fast is your mass falling and get an acceleration and velocity off of that. But basically your two key measurements here and the ones that they were looking for were some way to get a torque off of it and some way to get an acceleration or change the velocity off of it. Because those are the two things you really need to know to figure out how is it changing, because by definition a torque is an external torque is changing its velocity. So for example, if you were taking data off a LabQuest, you could put, can you see this still? Yeah. You could put a motion detector down here under your mass. And it will give you a velocity time graph. And remember, we can get to velocity and time by doing this. Your angular velocity times your radius is going to be equal to the velocity. So you can go back and solve for these things there. This would not be in part A. This would be in part B, because you're describing how you're taking the data and changing it into something useful. This of what data we're taking and how is part A. Part B is the equations and how we manipulate the data to give us what we want. And so when you're doing this, regardless of if you think it's right or not, there's almost always a point in here for just having A and B match. So just having the fact that I measured the things that I said I was going to measure gets a point normally. So make sure you are agreeing with yourself, even if you are not sure that you have the right answer, that's fine. But definitely try to keep it, there's points for being cohesive about your lab procedure, whether or not it's functional. So even if you're like, oh God, I really need to measure this thing and I need an imaginary tool. I had someone once make up an imaginary tool on the test. And yeah, they didn't get points for the imaginary tool, but that allowed them to do the rest of the problem and they got points for most of it. So if you're like, I need to measure this one thing and I have no idea how I'm going to do it, write that you're going to have some tool that does it and then, move on. Yeah, you're going to probably lose that point, but you can still get points for understanding how it works. And to move on to part C.
So like, what if you say, like saying motion detector, what if you said like angular velocity sensor?
Yeah,
like the gyroscope sensor.
I'm not sure if they would give you that point. I don't know if they would count that because some schools have those. I don't know if like all schools have those. So they may or may not give it to you, but again, you would still get points for the understanding on the rest of the problem.
Okay.
All right. Good question. So, and then C does the experiment described in part A and B depend on the assumption that the frictional torque is independent of the platform's angular speed? And so basically this is saying, was your lab consistent? And either answer is correct, depending on your lab procedure. So basically they want to check, do you understand what your lab procedure is testing? So if you were, say, Navi, and he was pulling it so that it didn't accelerate, when he pulled it, was it going the same speed every time? If it was going the same speed every time, then no, his problem does not depend on the idea that the torque does not depend on how fast it's going. However, if his speed was constantly changing, then he's assuming that the frictional torque is the same regardless of how fast it's going. Otherwise, if that assumption isn't true, his data would be all over the place, right? Because if the torque changed depending on how fast it was going, his data would be really weird if he was going different speeds. And so depending on how your lab was set up, your answer could either be yes or no. So if Navi was, say, pulling it at the same speed every time and checking, then it is no, it's independent. And so he would explain, well, since the fact that it's always going the same speed, that we are not worried about the frictional torque being independent or dependent because we're going the same speed anyway. We controlled for it. If he was going different speeds, he'd want to talk about how the fact that we're assuming it's the same, and therefore the fact that it's going at different speeds at different times should not change our answer. And so they just wanted to know, did you understand what you were doing when you created that lab? Because it's pretty common in real life when you make a lab and you're like, oh, you sort of just assume something is true, and then you look at your data and you're like, why is my data weird? And they're like, well, did you assume anything? And you're like, oh, well, I assumed this was true. And then you have to go back and figure out, well, was it true? Was it my lab was designed bad? Was the data bad? Then you got to go back and try to redesign a lab that does not use that assumption. So this is actually, it's a difficult question. And actually, I think this question in particular on that year had some of the lowest test scores. So this question was particularly difficult for a lot of students. So if you felt that this question was difficult, you are not alone. This part C kind of makes sense because I think this is something we really didn't talk a whole lot in class this year. So it's understandable if that part is a bit iffy for you guys.
Wait, so what would you say we would have to get on the lab, per question, in order to pass? So the lab's out of, let's say, 5 points, and then
this is out of 12 points.
So if this is out of 12 points, and let's say they do 3 labs or 3 FRQ problems, then that would be
if they do
36.
if they do 3, they aren't doing a lab question. Lab questions always take 25 minutes. So if they are doing a lab question, they're doing 1 lab question and just 1 other question. So, and here's the thing, I don't know, normally it's that 50-75.
Mm-hmm.
I don't know how the curve is going to change because of this.
Because I heard they're gonna render the curve if there are a lot of people that get a high score, they might nullify the scores or something, or if they catch people cheating.
Yeah. So if they feel like they catch people cheating, they're going to definitely null whoever they think is cheating. I think bottom line, guys, is if you overall understand what's happening, you should pass. That's sort of bottom line. So I wouldn't focus too much on did I get this point? Did I get this point? If you overall understand the questions and therefore the answers, you're probably going to be fine. And so I don't want to do too much speculation on exactly how the test is going to be rendered because we don't know. And I don't really want to spend our time focusing on that. My goal is hopefully just to get us good enough at physics in general that we're all yeah, maybe I'm not going to get 100%, but I feel like I can accurately, answer most of these questions. I can put a good push on it. That's the goal. So don't worry too much about the point counting because we don't even know what our point ratio needs to be at this point. But so don't worry too much about the points. For everything we do, check, did I understand all parts of it? What parts am I still confused on? And we can work on that. There's definitely some multiple choice questions where no one got them right. So we're going to go over those and figure out what happened. But and then D.
Mr. Coy?
Yes.
Are we gonna go through the whole test today?
I don't know. How are we feeling? Can we do this or do we need a break?
Can we like finish it in like different days?
Yeah, so let's just do like the FRQs today, and then maybe
Yeah.
the multiple choices.
That's fine. Are we able to get through the FRQs today?
Yeah, I think so.
Yeah.
Okay. Yeah, I figured. I was going to originally go through it quick, but this is turning out a little more in depth than I originally thought. So, D, describe how the experimental procedure describes in part A and B could be modified to determine whether the frictional torque stays constant as the angular speed changes. So basically this is like C. So regardless of how you did it, how could you do it so that you change the angular speed and then figure out, did it compare? So in Navi's case, where he pulls it at a constant rate, he would just pull it at different constant speeds and then test it. In my version, where I hang a mass over it and let it drop, I would change the mass, which will change my acceleration, which will change my speed. And then check every time, do I get the same frictional torque or not? And so that just wants to check with, now that we've tested for torque, can we now tweak it and test for something else? Which is, again, is a common lab thing, is you do a test and you're like, well, I'd answered this question, but we have opened up new questions, so how can we modify our test to answer those questions? So I'm gonna move on, again, in the interest of everyone's time, to 3. And then I do wanna have time to just answer any like miscellaneous questions at the end, and then people can go. So question 3 is that physical curve one. So I actually really like this question, but I know it was confusing for some people. So basically, the idea is, as we drop a ball into oil, what happens? If you were to drop a ball into oil, what's going to happen?
The
It'll
ball would slowly
drop
sink to the bottom, but then the oil, depending on like how, like depending on its viscosity, like it would slow it down.
Yeah. So basically, it'll slow down, and the thicker the oil is, the faster it will slow down, the more energy it loses. And so that's what that graph shows, is that the stiffer or the thicker the oil, it gets closer and closer to losing all of its energy. What type of energy are we really talking about as it's moving?
Kinetic.
Yeah, so yeah, it has some potential because of that original distance, but really by the end, we're looking at how much kinetic energy it has lost. So basically, it's coming to a full and complete stop inside the oil. So part A is give a physical reason why the curve cannot reach that E max. No matter what temperature they take it. So
I thought part 8 was it wouldn't. Oh, okay, never mind. It's talking about the vertical axis, right?
yeah, so it's talking about the vertical, sorry, and
Okay.
part B is E max. So they're asking, and this is one of the confusions that a lot of people have. Ooh, this board is getting ugly. So we're looking at why is that graph never going to touch the x-axis? Or excuse me, the y-axis. Why won't it touch?
So it says like the physical reason, like what I was thinking of is that it would pretty much say that the oil has no thickness, and in order for that to happen, the oil would pretty much like not have to be there.
Yeah, and that's pretty much all they're saying, is that if the stiffness of the oil is 0, which it can't be, that means that the oil doesn't exist. There's literally nothing there. And so that's ultimately why we can never get to this y-axis, is because the oil exists, our stiffness will never be 0. And so that's what they mean by a physical reason. It physically cannot have a stiffness of 0. And so that's for A. For B, as S increases, my stiffness, as S increases, we approach this maximum E max. And so they want you to write an equation in terms of MD and physical constants. So what is our maximum energy that we could have lost? How much energy, or what type of energy did it start with?
Potential.
Potential. How much potential did it start with? What's my equation?
1.5. Oh wait, MGH.
MGH.
Right. How high is it?
D.
What's its total energy it started with?
Emax.
Yeah, so what does Emax equal to in terms of M, D, and physical constants?
MGD.
MGD, that's it.
I was saying that the whole time. My thing was mute.
That's fine.
I was like, why isn't she hearing me?
So your Emax is just equal to MGD because, and actually, let me see. I might not screen share, but anyway. So this is equal to MGD because, sorry, I wanted to look at a bigger screen for my screen. So it's equal to MGD because that was the total energy it started with. We cannot lose more energy than we started with. It's not possible. So, and that's basically how you can justify your answers. You physically can't lose more energy than we started with, and we started with potential. C, one of the scientists is trying to represent the relationship and writes down the equation to we lost equals some constant. And so whenever they have these C constants, you can literally just be like, scratch them out, we don't care, it's not important. The important thing is that, does this make sense? Is that plausible? Or I guess basically they already told you, this can't be correct. Why can't this be correct?
Because that would mean that the graph should be, oh wait, never mind.
No, keep going.
Wouldn't that mean it's quadratic rather than?
Yeah, so it would be like a parabola.
That would be a parabola. What else? That's one thing you could have said.
Oh, it's saying that the wait.
There's one big thing, because they're really about do we understand the main concept? And the main concept here is conservation of energy still. What is wrong about this with conservation of energy? It has to do with the
Oh, because isn't with energy something increases, something decreases, but in that they're proportional or something?
Not quite. It has to do with the range of this.
The limit?
There's a limit. This is going to have essentially an infinite range. It'll just keep going up. Like your energy loss will just go up infinitely. We already said that can't physically happen. We have a maximum amount of energy to lose. Our E will not go bigger than that. And so I think that was the one they said you had to have. You had to talk something about how this goes up to infinity. There's no limit, and it needs a limit. And then any other thing would work. The fact that it's a parabola, the fact that this is a square root-ish graph, the fact that it doesn't touch here. basically any other graph fact would work here, but the one they really wanted, because I believe this was a 2-point question, the one they really wanted was the idea that we cannot lose more energy than we started with, and this is going to very quickly go over that limit. And then for part D, so again, they are again further attempting to model this. So then instead, they're like, okay, well that was a sucky one. So let's make up this one.
Wait, so going back to the graph before, would it just be that that equation suggests that the energy lost would just be infinite?
So that's 1 point. That's 1 point, and then any statement about how that equation does not match the graph.
Oh, so like the parabola and
So
then
you could say parabola, you could say the range, you could say the fact that it doesn't touch the like there's a lot of different things you could say. The only one they specified specifically is that this, the square increases indefinitely, and this one has a limit. But other than that, they just said anything else about the graph works. All right, so with this one, again, z is a constant, so I don't really care. But really, we're looking at this. Is the time indirectly proportional to the stiffness? Does this make sense? So as the stiffness increases, the amount of time it takes goes down. Does this make sense or not make sense?
No.
doesn't make sense.
No, because the stiffer the oil is, what's going to happen to the ball that's dropped?
The longer it's going to take to get down.
It's going to take longer to get down. And so that's really all you had to say about that. You had to explain something about how it should be. You would have first had to say something about how it's inversely proportional. If this increases, this decreases, or vice versa. And something that's saying that, no, time should be longer if this increases. So that was 2 points again. So something about what this relationship means, and therefore, why does it not make plausible sense?
Wait, so going back to like the explanations, I remember we talked about in class, can we do jot dots or do you say like do sentences?
Yes. You could do jot dots, but they should be complete sentences. So you can do bullet points, but the things stemming from those bullet points should not be words or thoughts. They should be a complete sentence.
So like in a way where they don't have to like interpret anything, like everything's just like laid out.
Yeah. So you can do like jot dots for organization, and I often do, but the phrase it can't be a phrase, it can't be a word, it has to be a full, complete thought. So make sure if you are doing jot dots, that's fine, but it has to be a complete sentence coming off of it. All right, and then the last one is graphing something about the change in kinetic energy as the stiffness increases. So basically they're like, okay, we're talking about E lost originally, and now we're talking about change in the energy, and specifically kinetic energy. So as stiffness increases, what happens to the change in kinetic energy?
As stiffness increases, the change in kinetic energy decreases, right?
Right, why?
Because the thicker the oil, the more kinetic energy it loses.
Wait,
right?
so tell me how to draw it.
I was thinking it would be like kind of like how the original graph that they gave us was. I thought it would be like that.
So like this?
Yeah.
All right. So anyone have any other thoughts, concerns?
Like it flipped.
Oh no, it would be flipped. Yeah. So like it would be reflected. Yeah.
Yeah.
No, the other way. Wait, I think I'm confusing myself.
Okay. Alex, you want to take over? Because I think I heard you talking.
I was just thinking that. I think when I did it, I said that because I looked at the actual kinematic equation, 1/2 equals mv squared, and then looked at the velocity,
Mm-hmm.
and I forgot where I went with it with that, but I think it was like, um, yeah, I forgot. But I looked at the equation.
Got it. Okay. So it would be this. Let me just check my points here. Concave upward. Forward, down. Okay. So key points here. This concave up. So basically, the higher the stiffness, so we're looking at if it drops and speeds up, then we're gonna have a high change in kinetic energy. The only time it speeds up is when our viscosity is low. So it's a very, thin oil. As our oil gets thicker, our object is probably still gonna fall, but it's really not gonna speed up. So we're not really gonna get much change in kinetic energy because it's not speeding up. And so one thing they say, they don't want this to go to infinity. Because just like we didn't have an infinite amount of energy to start with, we can't have an infinite change in kinetic energy because we started with some maximum amount. Theoretically, the most we could ever change kinetic energy is whatever our mgd was, because we can't have more kinetic energy than we started with total energy. And then as it gets stiffer, it says it can touch. It can touch the axis. It doesn't have to touch, but it does need to have some low part here, and it should be concave up. Because I think what Alex was saying, how it's as my velocity changes my viscosity, this is K is going to be a 1/2 mv squared, so it's going to have some curvature to it. All right. How do we feel on that problem? Good to move on?
Yeah.
Okay. Ooh, question 4 is actually one of my personal favorites. So question 4 is that pumpkin problem, and it's a paragraph response. So first of all, what is going to happen?
The arrow hits the pumpkin, and then it's supposed to fly back a
It
certain
either
amount.
Yeah, it either goes through it, it hits it, then bounces back, or it like hits and then it goes through it and then they move together.
Oh wait, they called it embed, I think. Embed.
Yeah, it was like embed, pass, and then bounce.
Mhm.
Right. So what do we need to consider when we're thinking about how high does this pumpkin go?
The type of collision.
Yeah, so we care about the type of collision. What else do we care about?
Energy.
Yeah, the energy, because why does the pumpkin go up?
Because it has like energy is transferred to it into kinetic energy.
Yep, and then that kinetic energy is transferred into
How far up it goes.
which is called
Motion. Simple harmonic motion.
Momentum.
Momentum. I don't know.
what type of energy is that called when it goes up?
Oh,
Kinetic.
potential.
Oh, potential, yeah.
Oh,
So we get a transfer of momentum, which gives this some velocity, some kinetic energy. That kinetic energy will then transfer into potential energy, determining our angle of our string. And so this is a momentum energy problem. So we have to do both. It's mostly a momentum problem, but you do have to bring up conservation of energy and conservation of momentum. I think each one is worth 1 point and a 7-point problem. The order actually earns 0 points, but let's figure out the order so we know how to explain it. Which one do we think is going to have it go higher?
The bounce.
The bounce. Yeah.
Because momentum has to be conserved. So yeah.
All right. Then what?
Embed.
I think yeah. And then through it.
Perfect, because this actually is it. Your bounce is going to give you your highest angle, your embed is going to give you your second, and your pass is going to give you the least angle. So let's break down. I am not going to write complete sentences. Please write complete sentences on yours. Let's break it down. What are the points? There are 6 points you have to make, and the 7th point is for a logical, relevant paragraph.
So first, you could just talk about how the momentum is transferred for the bounce.
You want to talk about bounce specifically, or?
Oh, well, you could talk about all of them, but then, so like for like the bounce one, I just said because there's going to be opposite, because the arrow is, since it's bouncing back.
Wait, let's start with the simplest thing. What's the most important simple thing we have to say here?
Momentum's conserved.
Yep. You first have to explain that momentum is conserved here. I'm going to pick up this call because this is the 2nd time in a row someone's called me, so it might be important. Hello? Okay, is it important? Can I call you back? Okay, bye. Sorry about that. So, first thing, momentum. Then we can start getting into the individual things. So you have to in some way imply that the change in momentum of this is equal to the change in momentum of this, aka the impulses are the same. So something about how as this thing loses momentum, that momentum gets transferred to the pumpkin. So basically how the pumpkin gets momentum in the first place. And then some argument about how the bounce is the most important. So something about why the bounce transfers the most momentum. Normally the best arguments I've seen for this are where you talk about that since we have to start with some initial momentum and later my arrow is going the opposite direction, that means the positive momentum for my pumpkin has to counteract this new negative momentum from the bounce. So that's why your pumpkin is going to need even more, or is going to have even more forward momentum, because our bounce now has negative momentum. So something along those lines.
So would it be fine, because like for this one, we were allowed to take pictures and like upload them. What I did was for my work, I put the equations, and because like I put the constants as 1, and then I tried to explain with the like the answer that I would get through the equations. So like I would set the velocity in order, because I try to use a velocity out of the momentum equations. So I would just like separate the final velocity of the pumpkin.
Okay, so I'm actually looking at your answers right here. I'm downloading them.
It's a little messy, but.
Okay, so be careful. All right, nope, none of that would count.
Damn. I didn't use the energy part.
No, none of that would count. You would probably get 0 points for that. So when they say paragraph, they mean paragraph. If it's not a paragraph, it's not getting points. So you can use equations to help you understand it, but your response must be in paragraph format or at least sentence format. So if they ask you to derive, you can do equations. If they don't ask you to derive, they want you to write it. You can use equations to help you understand it, but your equations are not your answer. They are just work that is helping you. But that will not be graded. So regardless of how correct or incorrect any of the written work is, if it's all equation and they wanted a paragraph, they're not going to grade it.
Tough.
So yeah, so if it's a paragraph response, make sure you are writing a paragraph. All right, now I want to get going because we're already at an hour and a half and my voice is starting to go. So the bounce transfers the most, then something about how the pass arrow, this is where I missed a point when I did this one, about how the pass arrow has a faster velocity, therefore it kept more momentum. You also had to do something about
Mr. Corey?
Yes.
When we do the pass justification, can we say something about how, like, if the arrow goes through it, doesn't it, I don't even know if this is how it works, but doesn't it have to go straight even when it leaves the pumpkin after it goes through it? Or can it also leave it at an angle?
Theoretically, it goes straight. On the idea that the pumpkin is uniformly dense. Realistically, it would probably go mostly straight. I would not worry about like.
So can we use that as a
angle changing? I would not use angles in a problem where they don't discuss angles in that sense, because that would get kind of hairy. I don't know if they would count anything with a reason.
Okay.
That's interesting. Yeah, I don't think they would count that. Because what they're basically looking for is the idea that the path is going to transfer the least momentum because it's still going fast. The embed is going to slow down. The bounce is just going to completely change velocity, so it imparts the most change in momentum. That's what they're getting there. And then you have to do something about energy conservation being the reason why it goes from kinetic energy to potential energy. So something about how energy conservation controls how high your angle is. 1, 2, 3. Oh, I missed one in there. Oh, and then something about how the arrow that slowed down the most transferred the most momentum. And then the final 7th point is not saying anything extra, not saying anything incorrect, and having a clear, cohesive paragraph. All right, I'm going to do the last one now, and then I will take questions, and we will be done for the day.
There's another one?
That was number 4.
There's 5?
Yes.
Oh, I thought this was the last one.
No, the last one was a graph one.
Oh, the waves.
The waves, yeah.
Right.
Okay, so the very last one is a wave one. And again, I'm not going to spend as much time on it because this isn't going to be on the test. Which is why I highly think they're going to do 3 questions, because normally it's a 5-question test, and 2 of the questions, one is circuits and one is waves. And if they take out circuits and waves, that leaves us 3 questions. So I think they're going to go with a 3-question test, but I do not know. But I will keep you up to date as I find out more information. Okay. So the first question was, at the instance shown above, aka a straight line, does the wave pulse carry energy? Because basically they said, well, we had a wave pulse going toward the wall, and then it bounced back. And so they said, at a certain point, it looks like this. And so, yes, no, does it have energy? What do we think?
No,
Why?
because energy is shown in a wavelength through the amplitude, and if it has no amplitude, that should mean it has no energy.
Okay. Do we all agree with that?
Can you say that again?
Yeah. This is before, this is after. The question is, so you know how when waves bounce, if they bounce back and they will have some destructive interference right here.
Mm-hmm.
So at a certain point, your line will look flat. Does it still have energy here, or does it not have any energy here?
It still has energy.
Okay. Why would it still have energy?
Because after the total after the superposition, they still keep going, and then it's still stored in the medium. Because what I said, it was like, it's just superposition. It's not that the waves, like, they just like overlap.
Okay, so the unfortunate thing is both of those answers would have received, it was only a 1-point question. Neither of those answers would have received points.
God damn it.
It's not a yes or no.
No, it is
Just-
1, but the answer is 0 points. The explanation is 1 point. So the answer is yes, that it does have energy. There are 2 ways you could have explained this. The way I would have explained it, energy is conserved. There's nothing else acting on our system. Therefore, whatever energy is there is still there. Nothing else touched it. So you could have done conservation of energy. Or, if you guys remember watching the waves, we have our wave moving. When it does this seem to happen fast or slow?
But when what happens?
Yes.
When this happens, when we see that destructive interference, does that interaction happen very fast or slow?
Fast.
Fast. And that's because, Alex, you were right about this. This is a potential energy situation. And you're right. Right here, there's no potential energy, but it's moving faster because of that. So you either could have mentioned conservation of energy or alluded to the fact that it is moving faster here. And that's why it's so hard to see that without a slow-mo camera, is because this interaction happens extremely fast because it has more kinetic energy at this point. It is physically moving faster. So the amplitude is a measure of the energy. It's particularly the potential energy. At this point, it still has the energy, but it's not potential energy. It is kinetic only.
So we would mention the conservation of energy.
Yeah, that is one way you could have gotten that point, yes. All right, and then part B was if we create, so they create a second symmetric wave pulse traveling to the right. The amplitude of the second wave is half the amplitude of the original. Which one travels at a higher speed? Guys, which one travels at a higher speed?
Can you say it again?
Neither.
Thank you, David. But basically, if someone created a tinier wave pulse and sent it on the string, which one's faster?
They're both the same because it's
Same
dependent on the
medium.
medium.
Yep. So the correct answer was neither, and then something about the medium, or they're on the same string, same speed, something about that. Good. And then the other ones are drawing problems, so I'll try to draw those nicely. I'm gonna screen share again because I don't think I can not draw them directly on it. Where are we? Screen share, screen share. I don't see my screen share button. Interesting. Oh, I'm just getting tired. Okay. And it logged me out. Great. Come on. Come on. Okay, so basically it was a wave problem. It was a reflection problem. So the idea that it bounced back. The main thing you had to consider is that it bounces back on the opposite side. So, ugh, such a pain. Classroom. Come on, computer. Overall, what did you guys think of the test?
The multiple choice was all right. The FRQ was a little bit challenging.
Okay. All right, almost there. And so yeah, probably our focus is going to be on FRQs 1 because there's not going to be any multiple choice. So we're going to focus on it. So hopefully you guys can see on my screen. So we have this original wave pulse right here. And basically what they're asking is what happens after it reflects, but only half of it is reflected. So basically we're drawing the line right here. This part is going to be reflected. This part is going to be at the wall. So I'm actually going to start by drawing what I have at the wall. And then this part is going to be reflected. What happens when we have something reflect against a fixed surface?
It comes back inverted over the other side.
So I'm going to do this in a different color. So this wave would be too high. Yeah. So it's 2 blocks high. And so are these going to add up or subtract?
Add
They'll
up.
add up.
So my returning string is going to look like what?
Double the
Both
height
added
backwards.
together.
Yep. So it's just going to be one big triangle. And so the black line is what should have been drawn. And then the next part of the question is now consider, clear my annotations. So now consider what's going to happen after some more time has passed. Let me really quickly check. Okay, so they don't give you a particular time instance, which means they don't care where it's drawn, just that it is drawn in completion. And so basically what you want to draw is an inverted graph. And so what that means is as compared to our original, so our original looked something like we had a little one and then a big one, right?
Yeah.
And so what they're looking at now is they're going to be inverted both directions because the one that is now going to be it's now going this way. So the one that's in front is still my big one. So I'm going to draw my big one first. Oops, I drew it wrong, a little too far up. I'm going to erase that, sorry. So I'm going to draw my big one first at the correct line now. So the big one would be here, and then the little one will also be flipped, and again, it will still trail the big one. And so your graph should look something like that. And so basically they're checking, do you get that it's flipped, and now the order is flipped because the big one is still in front, but they're going to the left, so it's going to be further towards the left than the little one. I think that was it for points, yep. And so that was the last FRQ question. So I'm going to take off the screen share and then open it up if you guys want to ask any particular questions.